In this section, we are going to be constructing confidence intervals for our estimated regression equations. To illustrate how we do this, we're going to continue with our example for the women swimmers. We have constructed an estimated regression equation estimating the swimmer's weight given her height. Now let's suppose we have a particular woman that is 63 inches tall, and we want to use this estimated regression equation to estimate her weight. To do that, we're going to plug the 63 into the equation and come up with 106 pounds as her estimated weight. Now we've already shown that there's a significant relationship between height and weight, and we have an R-squared value indicating a very good fit. The estimated regression equation should then be useful in helping make predictions on the weight of women given their height. Now, these estimates, such as the 106 for the 63-inch tall woman swimmer, are just estimates. The question then becomes, how close are these estimates to the actual weight of the woman? And that's where confidence intervals have traditionally come in. Confidence interval is going to give you a prediction on where the actual weight is within a certain margin of error, so that we will know that the actual weight of the woman is somewhere within the interval. And that's what we want to construct here. There are actually two confidence intervals. The first one we're going to work on is called the confidence interval, and it is really estimating where the average weight of women swimmers who are 63 inches tall, where the average weight is. And then the next one, the prediction intervals, are going to be confidence intervals estimating the weight of a particular woman who is 63 inches tall. So we're going to do both of these. The first being the confidence interval, estimating the mean value of y for a given x. Now the key word there is estimating the mean, the average weight for a particular woman swimmer's height. And the formula for that is, now this formula looks kind of complicated, but I hope you can recognize that what we have here in the box is a confidence interval. I have an estimated value. Now this is interesting syntax or notation. I've got a y star with a hat on it. And what this is indicating is the estimate that we get for a particular value that we put into our estimated regression equation. In this case, for our example, the y star with the hat is the estimate given by the equation for the particular height of 63 inches. So the value for this, the y star with the hat, is actually our 106 for a particular value of x. And in this case, our particular value of x is the x star 63. Now, what the confidence interval is doing is it's creating an interval estimating where, in this case, the mean value of y is for this given value of x. In other words, what is the 95% confidence interval for the average weight of women swimmers who are 63 inches tall? That's the interval that we're calculating. To do that, I need to gather some more values here and use them to calculate the standard error given by this formula here on the right. Okay, now n, remember our sample size. We had 5 data points to create our estimated regression equation. Our x star, we've already discussed, is going to be our 63 in this example. Our sample average, calculated earlier, the average of the values for the independent variable x turned out to be 65. Our summation here in the formula, taking each of the individual x values from our data points, subtracting the mean from each one, squaring them all, and then adding them together. We've calculated that before when we were creating our estimated regression equation, and that turned out to be 20. Now the other value we need here for our standard error is s. Now s squared we calculated or estimated with MSE. This was back in our test for significance when we were running the f-test. And recall the formula for that. That would be SSE over n minus 2, where the n minus 2 would also serve as the degrees of freedom. If you remember the values, you can look back and see them. That'd be 51 over this 3, 5 minus 2, which would be equal to 17. Now s then, which is going to be the square root of MSE, which would be equal to the square root of 17, which is approximately 4.123. Now putting these all in our formula, we have 4.123 times the square root of 1 over 5 plus 63 subtract 65 squared, which would just end up being 4, right? And then the summation. Now again, I want to warn you that this summation is actually, you set up a little table to calculate it, because each of the x coordinates of our 5 collected data points, each of those x coordinates, for each of those x coordinates we subtract the average, and then with those values we square each one of them, square each of those differences and add them all together. Now we've done that calculation, and you may want to refer back to when we were creating our estimated regression equation originally, but we got 20 for that. So you want to double check to make sure you understand what that summation is, how that's calculated. So our standard error then is given by when I go ahead and calculate all that together, 2.608. Okay, now the other thing we need is our t-value. So t alpha over 2, we're doing a 95% confidence interval, so that'd be 0.025. That would be the column we're going to look at in our t-table. And the degrees of freedom is coming from our MSE. So that would be n minus 2, sample size being 5. It's actually the denominator of MSE. So we have 3 degrees of freedom. With 3 degrees of freedom, and in column 0.025, I have 3.182. Now, finally, putting all that into our confidence interval formula. I've got 106, that is my estimate from the estimated regression equation given the height of 63 inches, plus or minus 3.182 times our standard error, 2.608, and that gives me a margin of error, multiplying those last two values together, of approximately 8.3 pounds margin of error. If I add and subtract that to my 106, I get 97.7 to 114.3. Okay, I can say with 95% confidence the mean weight of 63-inch tall women swimmers is somewhere between 97.7 pounds and 114.3 pounds. So my best estimate for a woman swimmer that is 63 inches tall is 106 pounds. I can also say that the mean weight of women swimmers who are 63 inches tall is within 8.3 pounds of that 106, or somewhere between 97.7 and 114.3 pounds. Now, the next confidence interval we want to do is a prediction interval, and it is predicting the weight of a particular woman swimmer who is 63 inches tall. For that one, we have the formula. Notice that the standard error here is given by a different formula. As a matter of fact, it's going to end up being a larger number than what we had for the previous confidence interval. And we would expect this since the variation in an individual woman swimmer's weight, given her height, would be more than the variation in the mean weight of women swimmers given a height. So in this case, the confidence interval, called the prediction interval, is going to estimate a particular woman's weight given her height. So with 95% confidence, if I have a woman swimmer who is 63 inches tall, what is the confidence interval for her weight? Okay, now let's go ahead and calculate that, and then we'll interpret it. Now the formula here for the prediction interval is very much like the one we just used. I would say that the only difference is, except for some notation, the fact that I've added a 1 under the radical sign for the standard error. So I'm going to plug back in all the values where we plugged them in before. And then calculating that on my calculator, I end up with 4.878. My t-table value based on n minus 2, in this case 3 degrees of freedom, 0.025 in the upper tail. I get 3.182, the same as before. And now I'm going to plug everything into the confidence interval. My estimated weight for the woman swimmer of 63 inches tall is 106, plus or minus 3.182, and then times a different standard error value, 4.878. And then let's go ahead and calculate the margin of error. So I have 106 plus or minus 15.52, giving us a confidence interval of 90.48 to 121.52 pounds. to interpret the confidence interval, the prediction interval, it would be with 95% confidence, a 63-inch tall woman swimmer has a weight somewhere between 90.48 pounds and 121.52 pounds. Notice that this is a wider range than the confidence interval for the mean. If we want to get a more accurate estimate, then the one thing we could do to decrease standard error, as what we've always done, is to increase the sample size.